Hi everyone, my name is Woo Seop-Jung. I'll be presenting our paper entitled LAX-Score. Lacrosse is a team sport that is similar to other team sports. So, our study aims to enhance team performance in general, not just in lacrosse. In order to enhance athletic performance, a team needs to understand whether their current performance is satisfactory. However, in many sports, there is no strong measure for game performance. Two methods can be used. First, game results does not evaluate the actual quality of performance. For example, a team could play well in a losing game and vice versa. Second, game notes are short narratives summarizing what occurred during the game. In game notes, we can see that the losing team played well against the high-ranked team. However, it is subjective and qualitative, so we need a better performance indicator. How does our metric look like? It is simple, but very intuitive. There are several metrics in other sports. However, these are for individual players' performance in team sports, and there's no statistical benefit of using them. On the other hand, our metric tells team performance with statistical significance. And collegiate sports did not fully utilize prediction power of machine learning. So our study is one of the first machine learning studies for performance enhancement in collegiate sports. Our metric takes into account game statistics and environmental factors such as team ranking or game schedule. By using feature selection, we extracted the best features and the corresponding target rates. Based on the result, we derived the metric as follows. We first normalize each feature, dividing by its league average, and then multiply the derived feature weight to adjust the importance of each feature. Finally, it's a weighted sum model of the chosen features. There are significant benefits of using our metric. First, it is a linear function of the winning percentage. This makes it simple to determine the likelihood of winning games. Second, a LAX-Score follows a Gaussian distribution. For example, an LAX-Score of 70 represents the top 15% performance in the last season. We then validated these characteristics from the past 3 years dataset. Furthermore, a LAX-Score is a better indicator of real-world performance. These are two examples that support our claim. The first several columns are the chosen feature values. In the first game, the high-ranked team struggled with the opponent. They allowed more shots and conducted more turnovers in the winning game. Although the team won the game note tone sounds negative and the LAX-Score is also lower than the average. On the contrary, in Game 2, the low-ranked team played well against the high-ranked team but lost the game. In this case, the game note tone sounds positive and our metric also indicates high performance. Over hundreds of games in our dataset, games with positive game note tones tend to have higher LAX-Scores and vice versa. So, in short, LAX-Score has better intuition on game performance beyond wins and losses. Now, here is the second part of our paper. With our new metric, we explored what practice features are more correlated with high LAX-Score games. In order to do that, we first collected sensing data, and then conducted data analysis. The most important thing is that we applied our observations to the team for performance enhancement. Our coach Scott will explain the data collection procedures.
Hey y'all, my name is Scott Kuhn, and I was the lead athletics performance coach for the women's lacrosse team utilized in this dissertation and the coordinator of data science for the College of William & Mary athletic department at large. I want to provide a high-level synopsis of sport preparation and the relevancy of this work as it is situated within the domain of sport. What we are seeking to do is systematically and progressively expose athletes to bouts of training that prepare them for competitive demands and thus improve the likelihood of winning. The GPS and heart rate systems provide us with the means to understand the mechanical and physiological demands of the sport, and by combining this data with the practice planning framework that I was responsible for designing and implementing, we are better able to understand how the way we structure practice sessions affects emergent competitive outcomes, enabling us to aim for mechanical and physiological targets that are found to contribute to winning. This slide showcases the features that were collected, all of which are key underpinning determinants of the physiological and mechanical demands of the sport and are imperative to understand their influence on emergent competitive outcomes. Features were collected, downloaded to a laptop, and then uploaded to a cloud server on a daily basis after training sessions.
Using the dataset, we conducted causation analysis between practice features and LAX scores. These are the best regression models for each practice type. Low load and taper session models have higher adjusted R-squared values, so its explanatory power with the chosen features are better than other types. In each model, those are the chosen features. For example, a feature A17, which is acceleration deceleration count in loaded session, has negative impact on high LX scores. Finally, based on our feature analysis, we provided actionable guidelines to the team, like in this table. Then here is the feedback from our coach. Basically, they had observed an uptick in injuries before we provided our guidelines. Therefore, our study prevented potential injuries. In conclusion, our contributions are twofold. Thank you for your attention.